All right. Well, welcome everybody to our new live stream, second ever live stream on Construct with Civo. It's great to be here today. I'm here with my buddy, Mr. M.R. Rishi, our platform engineer from Civo. Rishi, would you mind saying hello and introducing yourself?
Hey everyone, I'm Rishi. I work as a platform engineer at Civo, mainly involved in the cloud native operations, and excited to be on the live stream.
Thank you so much. And I am John Dietz. I'm Director of Enterprise Cloud Solutions at Civo, and helping lead the Construct project. And we have some really exciting stuff to show today. We wanted to get into a little bit of AI and GPU storyline with Construct. Construct's a incredible platform. It's a multi-cloud platform. It's a hybrid cloud platform. It does everything from infrastructure management to application delivery, to cataloging your applications that you want delivered throughout your application infrastructure. It's multi-tenant, so you can distribute this IDP to your downstream organizations. You can run it as a PaaS. We happen to run it as a PaaS in the Civo cloud. There are a whole bunch of variations of how Construct works and how it can work for you. But one of the really important storylines that we wanted to make sure was obvious to everybody is an AI workload self-hosting storyline that we have available for you today. And we wanted to show a little bit about that. Um, and Rishi, before we get into demo territory, um, you've been around the block. You're watching this industry. AI has absolutely taken hold. You can kind of look back just, 2 years ago, and this is a different industry than it was just a couple years before. Um, and it seems like companies are finding a whole bunch of different ways to leverage AI in their software development practices in order to accelerate, in order to uh, do all kinds of things, whether it be in their app, in the way that they build their app, in the way that they test their app, in the way they uh, document their app, etc. Um, and it seems to me that uh, it's a little bit of a complex ecosystem, and there are trouble spots where people find it challenging to be able to build and run GPU infrastructure and successfully get applications hosted on that infrastructure and running. I wonder if we could just kind of talk a little bit about your view of like what some of those challenges are. Why is it hard? What is it about? Like, you might think that, if you're running Kubernetes, you could just, have a Kubernetes cluster like a good old-fashioned K3s cluster. And if you had some GPU-oriented workloads, maybe you'd be able to just run some workloads on that Kubernetes cluster. But there's details about the infrastructure that gets a little bit complex. Can you kind of give us a little bit of an understanding of like what those complexities are and where the trouble spots are in terms of understanding how to build infra and run sort of AI oriented workloads?
Yes, starting, I would say to bring up the platform and make it reliable and make it persistent is a challenge. Like for example, okay, if you are deploying a model on a virtual machine, that's okay, you proxy it and you use it. But to get that real world experience, to maintain that scalable experience and that SLAs, you need some solution that is more easy to use and deployable, and as well as you can change the infrastructure based on your needs. And that is something that's been challenging to most of the people, because these tools are not easy. I mean, there are like 1,000 options you can configure to get performance benefits. Like there are optimizations everywhere, and it's really difficult to make sure and keep track of what you have been deploying, what's where. So I think our construct as a product will really help to maintain that and make sure the platform is always up and running.
That's very well said. Yeah, no, it seems to me it feels exactly that way, that it's configuration detail madness a little bit. And having a space for you to configure the opinions of how you want your cluster to be provisioned, what operators you want to be installed into that cluster, and then what, not just what tools and not just what models, but what versions of each one of those tools and models you deploy to that infrastructure is paramount to getting a good operational self-hosted AI ecosystem. And Construct has this really nice way of giving you a space to organize what a workload cluster template would look like if you wanted to host GPU workloads. And then for applications that you want to run on that GPU-oriented Kubernetes cluster, uh, Construct has a really nice way to register an application that's easily deployable. So I was hoping, without getting into too much, slides and presentation and blah, 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 I'd love to just get into demo space, pull up some detail for our viewers about how these GPU templates are constructed, how they can use them, and take advantage of them very swiftly. Uh, Today, I was hoping that we'd be able to show cluster provisioning. We'd be able to show the fully provisioned cluster hydrated with apps that came from that template, and then the ability to deploy a registered GitOps Catalog app to that cluster to use it as like an AI backend so that we can stop using AI SaaS solutions and start using our own infrastructure to increase that sovereignty and that control of our data. Could we perhaps start by you pulling up a with some explanation of our GPU oriented workload cluster templates in the Civo paths?
Yes, 100%. So uh, my screen is visible.
Yeah, you're looking good.
Okay, so we'll be using the Civo Construct SaaS product, which is hosted on Civo. And I think, as mentioned, sovereignty is becoming more important day by day. And also keeping in mind the price point, we would highly recommend using Civo to deploy your workloads. So you can go to the SaaS on the domain construct.saas.construct.io, and you can log in with Civo. And once you do that, you can view all your organizations. And for this demo, I'm using Civo internal services. So for the deployment of a cluster, so as we had already seen the provisioning of cluster in our previous live stream, where you register a Git account, create your cloud accounts, right? So there's already my GitHub repository that is registered. I have already a Civo cloud account that I can use to provision my infrastructure. So we can start provisioning the workload clusters where we can deploy these models. So here I already have a workload cluster, which is a single node B200 GPUs. And so Civo offers a wide variety of GPUs, all the way from L40s, A100s, H100s, B200s, B300s. The list just goes on. You can get more information on the website. But for the demo process, I'll be provisioning workload cluster. So here we just have to select the workload cluster template, which will be just bootstrap, like provisioning the cluster and also giving the bootstrap materials like Cert Manager, Envoy Gateway, Reloader to make sure your cluster is production ready. So I'm just going to be selecting a cluster, and for the demo purposes, I'll be selecting my internal cloud account, which using the region. And as you can see, we are going to be using A100 for the demo purposes, and I will just choose AI dev as the environment. Then for the workload URL, so before, I think I want to mention this again, like how do these workload clusters get provisioned? So we follow Terraform based provisioning. And so whenever you onboard to the platform, I think we already seen a Git account is registered. So when you register a Git account, if you go to that GitHub repository, there should be a folder called Terraform Civo workload cluster folder. Over here, basically all the configuration for the workload cluster exists, like all the way from creating that cluster, also bootstrapping it with all the necessary roles and role bindings. The difference is when you provision a GPU cluster, it automatically sees, okay, this is a GPU pool, and let me deploy a GPU operator in that cluster. So that's how it provisions. So I'm just going to be referencing the Terraform that's present here while provisioning my cluster. So yeah, I'll just select cluster. Do you have any opinions? I'll just go.
Let's call it live stream. And then just for our viewers that might not already be deeply familiar with Construct, this is using one of our built-in workload cluster templates that we have upstream. And you might be wondering to yourself, well, maybe I don't want to create a Kubernetes cluster exactly the way that you're creating your Kubernetes cluster. Maybe I have different Terraform opinions. Maybe I have different tools that I want in each one of my workload clusters. And I just wanted to be clear to our viewers that the way that Construct works, we automatically register our upstream cluster templates, but we offer you the space in cluster templates to create your own cluster templates. You can start from ours and just add your tools to it, or you can just create your own from scratch. If you already have infrastructure as code, if you already have a bunch of platform tools that you love, we get that deeply, and we are architected in a way that allows you to plug those opinions about your IAC and your platform tools into the Construct application so that you can deliver your clusters your way still. But we also have some fully operational architectural blueprints, if you will, that we keep upstream that are actually live and usable in all of the various clouds that we support. So when you see Rishi provisioning a GPU cluster here, this is one of our upstream templates that you just get to use for free. But if there were any opinions about the tools that were in this cluster that you needed to be slightly different for your organization, we fully support the ability for you to have your own cluster templates, register them with Construct, and use them as your implementation for your organization. So I just want to make sure that was obvious on the live stream.
Yeah, 100%. So it's very customizable and based completely on what and how your applications are dependent on what tools. So as you see, so we provision that, and this cluster is getting created, but it's gonna be like 2-3 minutes while the cluster comes up. But I want to show the cluster that's already in provision. So for each organization, we will get a Argo CD to manage that organization's infrastructure and workloads. So for internal management, we already have this Argo CD that's given for it, Argo CD dash clustering dot SAS.construct.io. So here, if I go to clusters, so you see the Hinaus AI cluster is already provisioned. And if you see, there's infrastructure and provider. So we depend on Crossplane. We have a fork version of it. We had made some changes to it. But along with that, we give you Envoy Gateway, Cert Manager, Reloader. And this one you see was the environment that was registered when that cluster was provisioned. So if I show the cluster details page, the environment hosted was EI there. And that's why that extra application is being visible. Good. I think if we go to the live stream as well. So once the infrastructure is up, it should automatically deploy the other applications like Cert Manager, Envoy Gateway, and also the AI dev environment that I had registered to it.
Thank you for that. Yeah, that's a really important detail to make sure we highlight that, like, when you provision clusters using Construct, unlike a lot of our competition, you're not just going to get an empty cluster in your cloud. You're going to get a cluster that's actually usable, valuable, that is ready for your workloads on day zero. So you click that create workload cluster, whether it be a GPU cluster or just a good old fashioned x86 or x64 cluster or whatever it might be. And your clusters will be pre-opinionated with our opinions about what it is that makes those clusters usable, ways to get certs, ways to get domain names, ways to manage your load balancer, ways to manage your volumes and everything. And then you have the ability to change what those opinions are and or just add on top of it. So it makes it a much faster experience. If you're just trying to get that app into a Kubernetes cluster and use it, it's all those prerequisite details that we take care of and make sure that it's super easy and frictionless. So thanks for bringing that up on screen. I appreciate that, Rishi. All those chicken and egg scenarios of getting the infrastructure first and waiting for it, and then getting the next app and waiting for it, and getting the next app and waiting for it, and wiring up all those details so that they all know about each other and everything works. That's kind of the hard part of Kubernetes that we're getting rid of. So.
100%. So we have already seen how you can onboard your code or your application onto a Kubernetes cluster. And that's what we covered in the app repositories part. But today we are going to be covering how do you deploy something that's already available in the internet and make it a better experience to deploy on the clusters that you provision. So that's the option that we have. GitOps Catalog, we had skipped it last time. But yeah, really got a chance to do this. So before I go, so GitOps Catalog is a way for you to register your application that is required to empower your platform. Like if you see here, there is cert manager on like external DNS, all the AI tools, like we have observability, ground cover, the name of like any application that you think is important to make sure your application is up and running, you can register that as an item and make sure that is deployable to any workload clusters that you provision. So for example, today we are going to be looking at, if I go to Civo internal services. So we are going to be deploying Kserve. So Kserve is a platform which will help, which will give you that base foundation to deploy models that can be used for inferencing, and the QN, which is going to be the model that we will actually deploy. So if we go to deploy the Kserve, actually, yeah, let me see if the cluster is already, oh, it's still provisioning. But I would like to, yeah, I'll just walk through it, make sure all these steps are covered. So we just have to get an app release name, then just select the cluster that you, so before that, how these values are populated here. So this is from our upstream templates. So so for example, if I just go to the information page on this thing, so the details of this particular item is coming from our upstream templates or Konstruct templates under GitOps Catalog Kserve on the main branch. So if I go to that particular branch and in that particular path, so you see, so this is a Helm based engine. So it's just going to be the values from the values.ml in this format that we opinion a bit about, like where you have to provide what type of variable that's going to be the description, whether it's a required field, and it can mean enum as well, and what's going to be the default value that you would like your teams or developers to provision that when they're deploying it. So that's where these fields are coming from. So
Yeah, that's a really cool detail to call out too, because like a lot of companies are leaning on technologies like Backstage in order to provide end users with a user interface to provide them a space to give you inputs for the stuff that you need, for the apps that you need, for the infrastructure that you need, for whatever you need. There's always got to be this middleman of being able to paint a form field to present to your users to collect their input and then provide it to your infrastructure as code layer. But with Construct, we've gotten rid of that layer altogether. Parameters are a native feature of our Construct V2 template engine. It's a Helm-based engine. And the way our cluster templates work is identical to the way that our GitOps catalog works. There are templates of YAML, basically, and that YAML has variables in it that you don't know the values to until it's time to provision one of these things. You don't know what the domain's going to be. You don't know what the cloud's going to be. You don't know what region you want it in. Details like that you get to define in your template. And then we have Construct prompt the end user, whether it's during cluster provisioning or during application deployment, whatever those key fields are that are important to get input from the end user, we're able to present that natively in the Construct application to the end user to collect that information and provide those values to the YAML, again, very cloud natively, so that you can have the exchange with the end user responsible for your infrastructure and app delivery without having all of the infrastructure needed to have like a portal. Like there's just no need for a portal if you get cloud native and bake the input parameters into your workload cluster templates and your application spaces. So it's a little bit of a revolutionary stance on how to manage inputs from users. And Construct is positioned in a spot where we have access to all of the information about your cloud and clusters that you don't want to care about. You don't necessarily want to care about keeping a list of all of your cloud regions. You don't want to necessarily keep a list of all of your different instance types for a portal to use to be able to present to an end user. Like you just want the stuff to work. So the way the GitOps catalog and the Construct clusters template, it puts those parameters directly in the administrator's hands so that they can prompt the end user for whatever's appropriate when you're creating these things.
Yes, 100%. So as you see, when we get populated those fields, the one that are mentioned as, okay, now it's required fields. Based on that, the options will be populated. And once you fill the necessary values that you would like to see in your application, we can just go to the provisioning part. So we can see the 2 workload clusters that were provisioned for these organizations are visible. I can select live stream and maybe select the environment as well and deploy. I think the cluster is still provisioning, but I already have Kserve deployed on my in-house AI application on the same environment. But you see, I think after the cluster is up, we should be able to see that in that cluster as well. I think it's just syncing up on cert manager and stuff. But without wasting time, I would like to show the one that's already been deployed, which
Thank
is
you, buddy.
provision cluster. So if you see the first 4 applications, those are the basically case of CRDs, the operators, the resources that is required, basically the foundation, as I told, to provision the models and inferencing. And Kserve does a lot of things, but we will be just checking on to how do you provision a model using that. So after provisioning the Kserve, okay, now we have all the necessary things. So let's now go to deploy a model. So for today, we'll be using Q1 model. Again, it's going to be the same pattern. You just have to register it as a catalog application and just follow the same steps of giving the app name, selecting or prefilling all the values. How we can just show. So you see the same cluster name, the namespace. Then we get a lot of options. Basically, these all are configured in the values.ml, and that's why we are seeing here the model name, storage UI, whether you want to cache it, use PVC, how many GPU you want to give, basically the tensor parallel size and all the extra stuff, and it's just going to be the same one. I'm not going to deploy this because I think the Kserve is not up, but again, we have already deployed that on our pre-provisioned cluster, which is our in-house AI cluster. So if I go to that application, so I had configured to use 8 replicas and each pod basically getting a single GPU because I have a B200. So if you take a B200 on Civo, you get 8 cards on each node or virtual machine that you provision. And yeah, that's how the model was provisioned. But how do we use this model? Like, how do we confirm that, okay, now you can use it in your day-to-day operations? So I think most of the people today are using some kind of CLI, and I think the famous one is Cloud Core. So I would like to show how you can integrate Cloud Code with the model that's been deployed and use it as an inferencing service
Awesome. If I
in-house. So
if I can interrupt you before you get into that chapter, just for the audience, wanted to make sure everybody knew that we had a Q&A section in our webinar here. If anybody has any questions about what's being shown on screen today, just pop a question into there. Happy to talk to it or schedule time with you afterward or whatever. Want to make sure that all your questions are answered. Please, Rishi, back over to you, pal.
yeah, so I have deployed this model over a load balancer service type. And let me share my terminal one second. Let me know if my terminal is visible.
We got root. We're ready.
Good. So I just have a Docker container with Claude CLI installed, and we just have to export the variable names. I can show. Yeah, Anthropic model, or then yeah, you can use the API as well. We will take the cluster in some time, but if you want to just make sure experience that, or you can sign on to the platform and use it. So if I just start the Cloud CLI and just go to like the model that I am on, so you see that we are hooked on to the QN model that we just provisioned. So if I just say how doing something like that, right? Maybe I'm bad at prompting, but so this is how you can use this one into your day-to-day like operations that you would like it can do more than how you're doing basically code reviews, all the documentation stuff, like basically everything that you would experience from the Opus models that you use on the enterprise version. So but basically this ensures that sovereignty and prices are within your limits and control within your limits. And how you, so this is how you can provision self-hosted AI using Konstruct within minutes. Like imagine doing this all through kubectl. Like it could have been done, but again, how do you maintain those 1,000 values that we 1,000 optimizations? Like this was just one model. Let's assume in a cluster you want like 3-4 models that you would like to use and use it for different purposes. So Construct really helps solve that issue of maintaining the infrastructure and making sure teams and developers are not disturbed and always are running. So
Yeah, it's a really good point. You know, uh, you look for the right way to leverage self-hosted AI, and it becomes transparent in in a couple scenarios. One is token spend. Token spend is enormous. You can kind of see as you scan online on LinkedIn, folks are scrambling to try to figure out the right ways to coordinate their token use and to be able to distribute and share and maximize the spend on these SaaS solutions. Engineers are getting rather creative trying to figure out ways to reduce their token spend, to optimize their token spend, to share their token spend. If you have your own GPUs, that problem space just goes away. You just get to use your GPU clusters however it's appropriate for you. And there are speed implications. There's usage implications. There's also privacy implications. Every time you talk to a SaaS AI solution, you're trusting their API servers with whatever information's going across the wire. And when you self-host your AI workloads, even self-hosting it in a public cloud space like Civo public cloud, you could host it in Civo private, obviously, and keep it all within your network. But even in the public space, at least it's on your private infrastructure in that public space, which is more than you can say for anything that's going to go across the wire and hit a public API server. So if you're working in a sensitive area, a lot of organizations that I talk to are working in highly classified, highly compliant environments. and they need that data to stay within the network. But they're still looking for the advantage that's coming out of this AI ecosystem. And it's tough to know the right way to put those pieces together in a way that's sovereign and safe for your organization to use in a way that doesn't expose your organization to leaks, to whatever it is that's going to happen in those SaaS ecosystems. If you're looking for a way to be able to run Kubernetes, to be able to easily install a couple components, to be able to configure your Claude code to hit your own internal private servers instead of hitting public RESTful APIs, then we're ready. And Rishi showed today that it's just a couple clicks to get you there. And that's really exciting for us. Um, Rishi, any final thoughts or closing comments before we consider this thing a wrap? I think that was a great demo. Showed the way that you could really use Claude Code on your own self-hosted Kubernetes ecosystem with your own models. I think it would be pretty easy to understand that like we deployed a model. But if you're heavy in the business of optimizing against different models and you need test beds to be able to deploy different models and keep those configurations in some kind of a sane delivery paradigm, we have that for you. We're ready. And so our hope is that you're going to see this. You're going to look at your token spend. You're going to see the risks that you have by depending on third-party services, and perhaps have opportunity to leverage Construct and our self-hosted clusters and self-hosted AI workloads to be able to do what you want to do more privately, more with more sovereignty. Um,
Yep. I think we have a question from John. What am- I love the platform and the UI. Love what you do. With regards to the agents, do you primarily utilize Claude or can other agents be utilized? So, I mean, I can take up the question. Maybe you can add your
yeah, sure.
thoughts. So this was how you can deploy models and hook Claude to whatever models you want and use it as agents. So we are not at all opinionated. We just want you to deploy that application and maintain the infrastructure and platform in a more convenient way, because it's just so massive world to be in, at least in the AI world, that it's really difficult for you to manage without having a product like Construct. So in-house, we use Claude as well. I think that's our main kind of AI agent that we have been using. But again, like depends on the models that you deploy, and based on that, you get the performance. And so hope that
Very well
answered.
said.
We have another one. It's for you, I guess. It's by
All right.
Craig.
Yeah, Craig says, John, when customers move from experimenting with AI to running self-hosted AI in production on Kubernetes, what are the biggest operational blockers you see? GPU scheduling, model lifecycle, data security, cost control, or platform skills? And how does Civo's approach simplify that for customers who don't want to become hyperscaler dependent? It's a really good question. And there's a lot of spaces to trip up, frankly. And a little bit of that answer depends on how you're using AI in your shop. There's all kinds of different ways that organizations are using AI. A lot of folks are using Claude Code and tools of that ilk to build their apps, to build their tests, to build their documentation. And that's one manifestation. But then there's also agentic flows in like natively in applications. And that kind of gets into a completely different space in terms of what the challenges are. But in terms of the problem space that we're trying to solve at Construct with Civo, we want to make it very easy for you to build and own and have that data sovereignty of whatever's important to you. And we know that AI is very important to a lot of organizations for a whole variety of different reasons. And we also know that creating that infrastructure is rather fraught with nasty details that conflict with each other and that are not in alignment with each other. So, you read one blog and it's talking about a model, you read another blog, it's talking about a CLI tool, you read another blog, and it's talking about how you can implement this with an SDK in your Golang code. But getting all of that together and operational and working correctly just has a lot of detail about it. And if you can get rid of all of the detail and provide at least a sane foundation for the models that you're using, how you deliver those models to your clusters, and how it is that you're going to version the delivery of those and test against them, that gets rid of 80% of a lot of the problems of self-hosting your own workload, your own AI workloads. That's not to say that it's all, easy after that and everything, just magic and sunshine and rainbows. Software development, still software development, and there's all kinds of challenges that you could run into, especially as you start introducing agents into it. But hopefully, we expect that with Civo's construct, you're able to get a workload cluster instantly, easily, way faster than the hyperscalers as well. Our cluster provision times are just leaps and bounds beyond anything that they're doing. And then with our Construct PaaS ecosystem, you're able to easily deliver complicated stuff, no matter what that complicated stuff is. So maybe it's a model, maybe it's your applications, maybe it's a whole combination of 15 applications in a microservice ecosystem, and all of it has to go together. We're ready for all of it. It can all be registered, it can all be delivered and distributed throughout your organization or your multi-tenant ecosystem, whatever that might look like for you. So I know I had to answer that one in a rather general way. Rishi, do you have anything you'd like to add to that? I'd also like to offer that, if you want to talk details, we're happy to schedule time with you and talk through anything at all that's specific to your organization. But Rishi, you feel
Yeah,
like
I
we
think
covered
that
that one well enough?
yeah, I think that was well covered. Uh, we have one more from, I think, YouTube. What is your default interval poll do you use for cross-plane Terraform provider? This is the first production app that uses cross-plane plus Terraform that I've seen. I'm wondering if there are any lessons learned. So it depends. So we do multi-cloud as well. So for Civo, I think it's 4 minutes, the poll interval. Now for AWS, the plan itself takes sometimes bigger depending on how long or how big your plan is. So it varies. But for Civo, I think it's really fast. That said, I think even if the provisioning time is so fast, we I think really focus on the performance. And yeah, so to answer that, I think it is 4 minutes. I just confirmed that. So
Right on. Yeah. And just in terms of the element of any lessons learned about that, ton of lessons. They're all baked into Construct. So you should definitely use Construct. We can also talk in depth about a lot of those lessons learned. It's a challenging infrastructure as code space to even talk about because Crossplane allows you to run Terraform. Terraform allows you to install Crossplane. They all depend on Kubernetes cluster that maybe you need those tools to be able to create that cluster in the first place. So it's a messy space. And we have mastered the creation of infrastructure using these tools, being able to surface the real runtime crossplane logs as clusters are provisioning. You're able to see that crossplane real-time execution. These are all capabilities that nobody's ever tried to put these tools together the right way, in my view. Construct is the first to really tackle being able to provision and put the tools in your hands, but put it in your hands in a nice, convenient way so that you can easily reconfigure them or change the opinions of what your platform does. So, great questions today. Do we have any others?
I think it was all.
I feel like we're good. Yeah. So before we wrap up, let me pull my screen up one more time. So I did want to just take a minute to tell the audience that We're very interested to hear from you. We want to know what it is that you want to see out of Construct, the different use cases that might be valuable to you. And if we don't hear from you, we're just going to keep showing you what we think we should show you. So the next episode that we're going to be doing is a month from now. It's going to be on June 17th. We're going to be doing an unplugged edition where we're going to be inviting some guests onto the show and really just talk about platform engineering honestly, because it is a nasty space. It's a space that I love dearly. And I know that there's a whole bunch of passionate engineers in the cloud native community that share that passion. We don't all share the same opinions. And I think it's important to get those opinions on camera and really debate them hard so that users that aren't that haven't had the privilege of working, in this platform engineering space for the last 8 straight years, can kind of learn from the do's and don'ts and the sort of competitive challenges as you go from tool to tool or architecture to architecture. So we're looking forward to that one. Hope you'll join us for that. Also wanted to take a moment to give a pitch to Relax AI. Relax AI by Civo is if you can imagine, even easier way to use sovereign Kubernetes self-hosted models where you're simply extending into a SaaS ecosystem. And we can do it in a way that is much more sovereign than anything the hyperscalers could ever offer you. And if everything that we're showing you with creating clusters and deploying models and blah, 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 if it all seems a little bit outside of your area of expertise, first, I would challenge you to hop in the Civo dashboard and start using Konstruct and just see for yourself how easy it is. But we get it. Sometimes you're a two-man shop and you got to offload some burden to some SaaSes. And Relax is there for you in that capacity. We've got a turnkey solution. You can hook it into your Claude code just like we showed you today. But you don't have to host your own infrastructure. You don't have to deploy your own Kubernetes clusters. You don't have to deploy your own models. You can just kind of use Relax. So wanted to make sure to get that on screen and wanted to make sure to pitch everybody to come back and see us next month. Rishi, thank you so much for demoing today. You're just such a star with being able to clearly describe some really, really complex topics in a grokkable way. And for anybody that was joining us today, if there's anything about what we showed you that is close to grokking, but not quite right, we'd love to schedule a demo and have some more private time with you. Talk about the ways that Construct or Civo or Relax can help your organization get going sovereignly with AI workloads in today's day and age. It's not hard to see how you don't want to be dependent on the wrong guys. And we think we're the right guys in the room. So I hope you'll join us next month. Rishi, thank you for the demo today. Audience, thank you all for joining us. And we will see you in about 30 days. Bye, everybody.
Yep. Thank you, guys.